Welcome G. Let's start Kotlin tutorial. Today I am going to discuss how we can use sealed classes in Kotlin. And the first we discuss the use case where sealed classes is really needed and what are the syntax and semantics, and the same we can discuss with example. So let us the scenario where we can going to use the sealed classes. Okay, so as per the definitions of the sealed classes represent the restricted class hierarchy that provide the more control over the inheritance. So, uh, all the subclasses of sealed class must known at the compile times. Okay, so generally, inheritance support there is a one class can have another subclass, can have another subclass, can have another subclass. So sealed class provides some kind of restrictions in the your inheritance process. So no other subclasses may appear after the module with the sealed class is compiled. Okay, the third party client can't extend your sealed classes in their code, and such instance of sealed classes has a type from the limited set that is known and when a class is compiled. What do you mean? Means that the sealed classes, if we have a one class, so here and this any you have to define the sealed classes. Okay, and these sealed classes have a multiple subclass, but all subclass should be in the same file first things. And whenever we are going to use at the compile time, these all subclasses should be known to the compiler, and these sealed classes no other file or no client code can access. So why need all the subclasses at the compile time? The some cases where we need like let's example we have a class your base. Okay, let's open for inheritance, and you can try say we have a class subclass sub class 1 extend your base, right? And might be we have another subclass class subclass 2 that extend base. So here you can say base class have a two. So let's give we have a one function let's see evaluate that take your uh, base class as the object, and what this say, let's they return like when b when your base class. So whenever you are writing the when expressions, they assume we have a expression b, uh, we have to provide some kind of what kind of a possible inheritance of b. So b maybe is base is maybe subclass 1 is subclass 1. Let's return subclass 1, or we can say is base class 2, then you return base class 2. But you know this class have a two subclasses, and according to the case match you can return the value. But here what the compiler say, when expression is must if exhausted and necessary else branch. Okay, so here say your base class can have a, here in initially compile time you have a defined a two subclasses, you have a mentioned two possible subclasses. It's still compiler need kind of a, you need a else block, else, else, else. And so now your code is no. If someone, let's keep println evaluate and you pass the subclass one. Okay, it works. What happen if let's in future, you know, we have to maintain the all the switch cases here, but what happen in future, let's key someone extend another subclass, but might be you have to miss, a developer can be miss this cases, this case is not evaluating your case 3. Okay, if you are trying to say case 1, case 2, case 2, case 2 and case 3, and if you run it, your this evaluate function is not know about the runtime someone implemented the new class. So in anyhow is there any here, at least we want at the compile times compiler enforce you, you have to miss this sub implementation here. Here we are missing this implementation of sub 3 class, but still compiler is happy. So in anyhow, is there any restrictions in this class hierarchy? So here a shelled class help us to solve this problem. If we are going to implement this is as a sealed class, okay, and then time you don't need the else block. And now here you your compiler say key this is a necessary, we have to missing the subclass 3. So here we have to compiler ensure ki you have to write your 3 implementation as well as. So here at the compile time, if B is a sealed class, then they compiler know ki this sealed class have a possible 3 implementation. So all 3 implementation must be specified in a case block. So if someone go and add another class 4, okay, and they are just going trying to use some more 4, but here you notice your function will break. You say you have to missing subclass 4. So this is the benefit of a sealed class. Whenever they are going to use in the some when expressions and you find runtime developer have created new subclass and here we are missing something, so at least we have need to add here as well as, then your code is works, right? This is the works. So sealed class just help us to uh, this is the just you use to modifier sealed for making any class as a sealed, and all the implementation 1 2 3 4 sub, whenever we are going to use in when expressions, first you don't need to write your else block, and you as a compiler enforce you, you have to write all the implementation here. Okay, so this is your use of your sealed classes. So to declare sealed classes, we have to put sealed modifier, okay, before its class name. Now it's a sealed classes. And similarly, we have example here. One is the class expression. We have a mark as a sealed, and let's see, we have a one subclass is a constant. Take one input, and the just is a subclass from expression, and another class sum. Take a two input variable and subclass from expression. So in this way, you can say sealed class is a abstract by default. So please be ensure that all the sealed classes by default abstract. That means you cannot create instance of object of that, and can have abstract member. So sealed classes are not allowed to have a non-private constructor. The constructors are private by default. So please ensure when you mark any class as a sealed, that means this is the abstract class, you cannot create object, and you cannot. Why? Because the constructor is by default marked as a private. Let's see your example. If you try to create the b equal to base, here compiler not allowed, cannot access. This is a, it is a private. So please ensure whenever you are going to the mark any classes as a seal, this is the abstract class and cannot create the object of that class. Reason, by default constructor of this base class would be private. The as we discussed, the key benefit of using the sealed class come to play when you use the when expression. Inside when expression, at the compile time, okay, if it is a verify, the statement cover all the cases, okay. Here compiler ensure that, and you don't need to add else clause as well as. So here, whenever you are going to use any sealed classes in the when expression, you have to provide all the subclass of this sealed classes, and you don't need to provide any else clause as well as. This is the optional if your class is your sealed class. If you are using a normal class as a without sealed class, then else class is always mandatory, and here might be you have to implement subclass 1, subclass 2, subclass 3 heretical, but might be something you can miss as well as. So if you mark this is a sealed class, then you have to mention all the possible subclasses, okay. This work only if used when an expression using the default, not as a statement. So this is the one kind of benefit where if you are using the when expression, and you want to ensure that all the subclasses must be considered in these cases, so you have to mark this as a sealed classes. At the compile time, compiler ensure you are not missing any case. And might be case somewhere you can use the seal as an interface as well as. So this is generally not recommended way. Might be in future Kotlin can disallow it, but currently you can interface can declare as a seal as well as a classes. Similarly, like if this is the last example, we have expression is a your seal class. Now you can just declare interface, and or now we have another sealed class that just implement this interface, and this sealed math expression interface can be have a subclass your constant value are not a number. So you have options, you can use interface also as a shield interface, but general way please use as a class as a shield interface is not recommended way, but Kotlin support if somewhere we need it we can. So this is the short explanation about the shield classes. Okay, any classes you can mark as a shield using the shield modifier. Just add a shield modifier, and please be ensure a shield class is ensuring all the subclasses of this shield classes must be in the same file where the shield class is written. Class 1 implementation, 2 implementation, 3, all the subclass should be in the same file where shield class is declared. This is the one. And shield class by default is the abstract classes, so you cannot create object, and all the constructor of shield class is a final. And the use case is that whenever we are going to use as a when expression at the compile time, compiler ensure you have to handle all the sub cases, means ki shield class let's ki have a 4 implementation, compiler ensure you have to handle all the 4 cases here. Okay, so in this scenario where you want such kind of a insecurity, if anyone can create some new classes, they must check all the uh, cases as well as, so you have to use the shield classes. Okay, that's good. And here again I am like to say thank you for watching this video.